Hi, hello everyone. Good afternoon, मेरा प्यारा बच्चा लोग. So before we start with the session, everyone yell out in the chat box and tell me how are you all doing. Okay. So in the meanwhile, okay, by the time you take some time to type out in the chat box, let me tell you what we're gonna do in today's session. But we all are very much close to our exam days, right? So it is very much important to start our revision classes, and that's the reason exactly here we are with the questions, right? By solving the questions from the very first chapter of part 2 physics, which is mechanical properties of solids, right? You all know it's a very important topic, and it is our responsibility to make this chapter so easy and to feel more confident about this chapter. So we're going to do almost 30 questions, and let me see, after the session you will feel so good about this chapter. You will be like, okay, there is nothing more to learn from this particular chapter of solid. So I hope you all are ready. Before we get started, let me say hi to everyone here in this classroom, and jaldi se jaldi फटाफट बता दे कैसे चल रहा है आप सबके साथ. How's everything going on with yourself? Lakshman, good afternoon. Hi, Miara. Amazing. Having good. Lakshman, just fine. Okay. So try to make the days so great and so awesome, Lakshman. Parneet. Yes. Okay. Now, if you are seeing me for the very first time, a bit of introduction about myself. I hope you all can get it from this slide, right? Okay. Now, moving on. Devika. Yes. Everything is going good. Quite good. Okay, now let me tell you, the link for joining the Telegram channel is given here and in the description box. And if you want any updates related to the classes happening in our YouTube channel, right, everything will be available in our Telegram. So don't miss it. This is your opportunity. Jaldi se click on that link and be a part of it. Bugs Bounty, what it is? And it's an amazing way for every one of you to grab some prizes. So if you find any inappropriate content in the videos uploaded by Unacademy, okay, just report in the form given in description box. बहुत सारा, खूब सारा prizes मिल जाएगा आप सब लोगों को. Now, I want every one of you, okay, to share the class and tell all your students. Tell them that, okay, and all, not students, I'm really sorry, to all your friends that, okay, the Bhaiya's class has started, and today we're going to do lot many questions from mechanical properties of solids. So go fetch every one of your friends and put them here in this class, okay? So I'm leaving that task to every one of you. So you guys are like the task force. Okay, anyway, so look, if you want to be a part of Unacademy family, okay, if you want to start learning with us, you have two different opportunities are there to be in the Plus subscription or the Iconic subscription. In Plus subscription, you will be given access to all the live classes, and whenever you miss any live classes, recorded version will be available. And obviously, it is going to simply better your learning skills and your marks, right? That is something promised in Plus. Now, if you go with Iconic subscription, in Iconic, you'll be given a personal mentor, right? Will be there to help you with your studies and plan all your study activities throughout. Okay. More than that, we can also expect a special doubt solving live classes will be there, and weekly reports will be given to you. So once you are a part of Iconic subscription, right, your skills, everything is going to be multiplied like anything. Now let's say if you go for 12 months of Plus subscription, it should cost you 1,250 per month. Okay, and as you all know, you don't need to pay that much, right? Kyunki we have our code AMB10. Get 10% out discount and maximum offers while you make the subscription. If you go for Iconic for 12 months, it should cost you 2,333 per month, and obviously we have our code for the entire physics family. Use it, get 10% of discount, and have an amazing life. And this is the best time to make the subscription, because if you go for subscription of 12 months or more than that, extra 2 months to mil jayega aasani se as a free. So don't wait, and this is only available for the first 500 subscribers. Make sure that you are one among those 500. Okay. So if you want to talk about the courses that is available in Unacademy and how it works, and if you want to get any idea about it, the number is given here for the counselor. You can just talk to that person and get a very beautiful idea of what is happening in our Unacademy. Now open house sessions keeps on happening. You can be a part of it, right? Okay. That's it, and now it's time for doing the questions. Are you all ready to spend the next 2 to 3 hours with me and to do as many questions as possible? Con ready? I'll just ask you. Who all are ready for this 3-hour session? Almost, I'm planning to make 3 hours. I don't know how long it is going to be. So I came with some almost 30 questions, and let's see how many questions we can solve by today. It all depends on how fast you're going to do it. Okay. So jaldi se jaldi फटाफट बता दे. Hi Shruti. The title mentioned in various. Oh, okay. Maybe there was some difference. Okay, maybe some कोई गलती हो गया क्या? Maybe there was some mistake when the title was created. What about right now? If you look at the title for the class right now, is it the same or is it different? From start till end, wow, that's a great big promise. Make sure that you have listened to this time. It's 3 hours almost, right? Good afternoon, Mithilesh. मेरा दिन तो बहुत बढ़िया था जी यार. And it's good that many of you are finding time to be here in this class, even though you are having school classes and all. Okay, I do really appreciate everything. Okay, it's correct here, right? ठीक है मेरा. Ravinder, hi Ravinder. Okay, now I think I don't have to ask you bachalo whether you can see the question or not. Question is visible, so whom are you waiting for? Go and attack the question, get the correct answer. Go for it. Okay. So this will be a session where you will be giving me the answer instead of me just explaining the question and doing the solutions here. Okay. Yes. Oh, it's today is a holiday for schools. Why? Reason? What is the reason? Is there any reason which I'm not aware of? Take your time, try to do the problem properly, and the numerical is not so tough because easily 1.5 and all cancel. You'll find it once you do the problem. Okay. Okay, no holidays. It's just like you got the second dose and you wanted to take rest. Okay, fine, got it. Okay, I can see option C by Mithilesh, option B by Jia. Gayatri, hi, hello. Okay, I think I should start explaining. Fine. The correct option is, or by the time I do, you still can give me the answer. Okay. देख ले. Determine the elongation of the steel bar. Elongation is usually represented with the symbol of delta L, है ना? Okay. Of length 1 meter long, initial length is given, and area of cross section is 1.5 centimeter square or 1.5 into 10 power minus 4. Okay, when subject to a pull, matlab a force is also given 1.5 into 10 power 4, right? And Young's modulus is given here, and the question is just to find delta L. You all know how to find out, and it's not a big task, right? कैसे कर सकता है? Just write down the basic formula for Young's modulus of elasticity. That is F L divided by A delta L. We want to find delta L. Take this delta L from denominator to the numerator of left hand side of equation. So delta L हो जाएगा F L divided by AY. अरे अब क्या बाकी है? कुछ नहीं है. Just substitute the values, get the answer. I hope the bottom part is also visible. Can I write here? कर सकता है ना? Okay, not a big issue, I suppose. I hope you all can see even if I write the values. Anyway, force is given as how much? 1.5 into 10 power 4, and length is 1 meter. Okay, fine. Then area and Young's modulus. Area is how much? 1.5 into 10 power minus 4, and Young's modulus is 2 into 10 power 11. Okay, 1.5 cancel, 10 power minus 4 goes up, 10 power plus 8 हो जाएगा. ये दोनों मिलकर 10 power 11 goes up, 10 power minus 11 हो जाएगा. So 10 power 8 into 10 power minus 11 is 10 power minus 3, and 1 by 2 here we have, देख ले, here we have 2 on the denominator. 1 by 2 makes it 0.5. So this is 0.5 into 10 power minus 3 meters or 0.5 millimeters. Option C will be our answer. Cool, right? No question tha. You just should be knowing the formula for Young's modulus. Just rearrange, put the values. Okay, get the answer. Correct answer, right? Who all gave me the answer after that? Lakshman, Devika, Miara. Okay, cool. So, shall we skip to the next one? Okay, dokie. C for cute cat. Okay. And from where this cat is coming? Meow. Correct. Oh. Go for it. Okay. All are in the units of atomic inverse, okay? Let me make it clear there. Forgot this. Atomic inverse. Okay, so do the problem accordingly. I hope you all know the formula for compressibility. Okay. From my house. Okay, you're talking. I forgot, Hannah. So I forgot about Marco. It's been 3 weeks here in Bangalore. 2 weeks, I suppose, right? So I totally forgot. No worries. I'll be going back to my hometown by this Monday or Sunday. So I can meet him. Done with this? Mithilesh and Gia is going for the option of A. Totally fine. Anyone else? Okay, Lakshman is like 1 by bulk modulus. So it's not option A. Anyway, we'll find out. Let's see. Right? Bulk modulus of water is given as 2.3 into, it is not 109. I think you already might have understood. It is 10 power 9. Okay. Question is, find its compressibility. Array, compressibility and bulk modulus ka relationship kya hai? Compressibility is equal to 1 by bulk modulus. That's it. Okay. Now we just have to take the inverse of bulk modulus. But here, modulus is given in Newton per meter square, but we want compressibility in atomic atmosphere inverse. So it will be better. Initially, we convert the unit of bulk modulus in atmosphere itself. Then it will be easy for us to get the answer. Okay. Bulk modulus ka value kitna hai? 2.3 into 10 power 9. Newton per meter square can also be written as Pascal. Array, Newton per meter square, force by area. So unit of pressure, right? Okay. So 2.3 into 10 power 9 Pascal we can write. Now how can we convert this Pascal thing into atmosphere? We just need to know the basic relationship that 1 atmosphere is equal to kitna? 1.01 into 10 power 5 Pascal. Okay? So for converting Pascals to atmosphere, kya karna hai? Divide kar le. 1.01 into 10 power 5. So that we'll get it in atmosphere. Fine. Okay. So how much this is going to be? 2.3 by 1.01 will be 2.27 into 10 power 4 atmosphere. Okay. So bulk modulus in the unit of atmosphere we got. So compressibility is not a big task. Hai na? Compressibility is equal to 1 by bulk modulus. That is 1 divided by 2.27 into 10 power minus 4 atmosphere. 1 by atmosphere. So atmosphere will go up as atmospheric inverse. 1 by 2.27 is a 0.4 into 10 power 4. Right? Okay, it's not 10 power 4 minus 4, it's 10 power 4. Right? So 1 by 2.27 will be almost 0.44 into 10 power. This goes up 10 power minus 4. We can write it as 4.4 into 10 power minus 5 atmosphere inverse. Okay, so there is no much theoretical part here. Only thing is you should be making this conversion, that's all. Okay, if you know this conversion rate of 1 atmosphere is 1.01 into 10 power 5 Pascal. I think everybody knows, है ना? सबको पता है. Is there anyone जिसको नहीं पता है? Like 1 atmosphere is 1.01 into 10 power 5. Everybody knows. So you just need to basically use this conversion, apply it here, substitute it here, let's say, and get the answer. Sir, you must be very rich. Your name says it. Arey Aryan. Okay, whenever a person can't be rich, okay, they usually attach the name to that person. At least that rich wala name is there with the person. So I'm that kind of a guy. Okay. without being rich by money, just having the name to it. Now clear? Okay, awesome. All good. So we got the correct answer as option B. Okay, moving on. Calling me liar? अरे बिल्कुल नहीं. Why should I lie? देख ले कुछ भी नहीं है. In which t-shirt you used to see me all the time? बोल ले. In which t-shirt you used to see me all the time? Whenever I come to class, अरे I'll be coming with the same black this Unacademy का. Okay, so I only have this t-shirt which is given by Unacademy. ना I was actually not having one, so Unacademy is like okay, at least पहन ले, ये पहन कर जा आप class पे. Okay, at least you will be having this t-shirt. I'm like ठीक है. Okay, ठीक है भाई. तो मैं जाएगा. So that's how I got this t-shirt. Fine. So now you just understand. I can't lie. अरे आईफोन, ये तो आईफोन नहीं है. चलो ये तो है ना, स्टिकर लगाते हैं हम. Haven't you seen this? If you go to what's this? If you go to mobile shops, you know, they usually give stickers. Sticker है. No. Never. अरे इसके जवाब दे दे. मतलब question is right in front of you and we are talking about t-shirts and iPhone. उत्तर दे दे. Answer everyone. Mithilesh going for the option D here, okay, which is 0.2 joules. Anyone else? Aha, we are Montessori kids and we don't know. Oh, okay, fine. So you guys approved yourselves. Okay, fine. Okay, everyone, Myara, Devika, Jia, Lakshman, Parneet, Vasu, Are, bilkul badhiya. Everyone is going for the option D here, let's say. So awesome, it's option D itself. Shall we see? कैसे करें? देख ले. A steel wire of 4 meter length is stretched through 2 millimeter. Length is given. The increase in length is given. Cross-sectional area is given. If the Young's modulus value is also given, the elastic potential energy stored in the wire. How many of you do remember the formula? We'll write in the next page. Hai na? How many of you do remember the formula for potential energy stored inside the wire when it is stretched? Formula is half Young's modulus. Okay, one of the formula is half into stress into strain into volume. So stress is being converted as Young's modulus into strain. So formula will be half Young's modulus strain square into volume. Volume I'm going to write it as area into length. Okay, now half Young's modulus. Tell me what is the expansion of strain? Change in length to original length. We have a square here into area into length. देख ले one length on the numerator and one length on the denominator get cancelled. So the net formula is half Young's modulus delta L square by L into A. This is it. And अब क्या करना है? कुछ नहीं. Just substitute the values and get the answer. Half. What is the value of Young's modulus? 2 into 10 power 11. Okay. Change in length is, I suppose, 2 millimeter. So 2 into 10 power minus 3 meter with the square term by initial length of the wire is 4 meter. Length of the wire is 4 meter and area is 4 millimeter square. That is 4 into 10 power minus 6 meter square. Okay. So I am leaving the task to you all people making the calculation. It's nannu munnu. And you will get the answer as 0.2 joules. Okay, which is the option D, which everybody have given here. Awesome it is. And I'm so happy that you still do remember this formula from the first chapter of part 2. Okay. So after doing these many questions, at least you might have understood, right, the kind of question that can be asked, from this particular chapter is not so big. Right, not so application level question. It can be mostly direct question, but with a small twist and turns here. That's it. Simple. Correct answer. Correct too. So what do you have to say about ring light? It is. It's a. All these are given by. I have a laptop in front of me. There is a camera in front of me. that studio ring, and the entire studio setup at my place, everything is by Unacademy. So obviously once I leave this place within this month, sab jayega ghar se. I'm just asking God, to Unacademy people, like, let's t-shirt, just give me this t-shirt, at least I'll have something to wear. So no doubts in this question, है ना? अगला question तो आ गया. Good afternoon, Sumit. Come on, sir, don't make us cry. Don't cry, Miara, be strong. Question is right in front of you, so just do it. They're clear. Be like Mithilesh. People are just talking about Amara phone ring lights and all, and Mithilesh in the meanwhile is solving the problems and giving me the answer. Awesome. Mithilesh is going for the option C here. Gia for option C. कितना time हो गया? We just started 20 minutes before, है ना? Okay. Vasu Patel. Everyone is going for option C. Arey, option B correct answer hai. Seems like no one is doing the problem from there. It's option B which is correct, which is 0.91 millimeter. Let's solve it. Dekh. The elastic limit of copper, matlab the stress that can be maximum produced on the copper so that the material can stay within the elastic limit is called as elastic limit. Okay? So the stress within the elastic limit is given as how much? 1.5 into 10 power 8. Okay, in a Newton per meter square. Matlab, this is the maximum stress that can be given to the body so that the body will be staying within the elastic limit. If we give a stress more than that, kya ho jayega? Right? It will lose its elastic property and it will be converted into a plastic material. We know that, right? Okay. Now, this is it, elastic limit. Now, determine the minimum diameter of a copper wire can have a load of 10 kilogram if its elastic limit is not to be exceeded. Now, for a material which is having this specific value of stress, if it's want to load a maximum weight of 10 kilogram, right, what should be the minimum diameter that it should be possessing? Okay, that's a question. Do you know how to deal with this problem? Simple. Stress का formula क्या होता है? Force divided by area, and that is given as 1.5 into 10 power 8. है ना? ठीक है. Now, it is given that the maximum force that can be given is equal to 10 kilogram. So obviously the force given by 10 kilogram will be its weight, that is m into g, let's call it as 10 divided by. Question is to find out the diameter a copper wire is having in order to safely contain this 10 kilogram body within the elastic limit. So how to find out the diameter? Simply expand for this area value. Area in terms of its diameter is pi by 4 d square. Right? Because wires, at the end it will be having circular base. Let's say its radius is r and diameter is d. For a circle, if its diameter d, its area is pi by 4 d square. Okay. And this value is given as 1.5 into 10 power 8. So d square will be, this 4 will go up. 4 into 100, let's say, divided by pi we have, which is 3.14. Into this 1.5 will be coming into 10 power 8 will be here, that is equal to d square. So d, if you take it, you will have the value as 0.91 into 10 power minus 3 meters, or which we can write d value as 0.91 millimeters. Which option will we get? B option will jayega, I say. Not a big task, right? You got D, none of this. Okay, yes. Any doubts? Let me ask you, whatever I am writing, is it visible to you? Is it of correct size? Yes, let me also see. Yes, I can see that. Once you put in the big screen, है ना, it's visible. Yes, Mansi, yes. जिया, लक्ष्मण, सब ठीक है, सब बढ़िया. So yes, moving for the next one. It's a good question actually. It's a good question. So question is like, identify the case when an elastic metal rod does not undergo elongation. In which case it is not elongating. Not elongating is the question. Okay. Thank God now net came. Net कहाँ गया था देविका? Identify the case when an elastic metal rod does not undergo elongation. So we have the answers from Lakshman as C, Devika C. Jia C. Yes, it's option C only. Most of you already know, right? ठीक है. Let's see, everybody. Very good. Right? So let's go through each and every options and let's try to understand why it is option C our correct answer. First one is, it is pulled with a constant acceleration on a smooth horizontal surface. देख ले, you have a wire. On this wire, to the right I am applying 10 Newton and to the left I am applying 6 Newton. Will there be a net force acting? Yes, 10 minus 6, 4 Newton. With that 4 Newton, can this wire accelerate? Yes, it will be accelerating towards right because net force is towards right. It will be accelerating. My question, during this time of acceleration, can it elongate? Yes, because there is a 6 Newton force towards left, and from 10 Newton there will be an equal amount of 6 Newton, है ना? Okay, to the right also these two forces are used for what purposes? For elongating that particular wire. Okay, so from 10 Newton, 6 Newton is being used in order to stretch that wire and the remaining 4 Newton is used for acceleration. इसीलिए net force is 4 Newton and the acceleration is based on that 4 Newton. समझ में आ गया? So in first case it elongates. Okay, but question is to find out which one doesn't elongate. So ये तो elongate है, so this is not our answer. Second one, it is pulled with constant velocity on a rough horizontal surface. Okay, देख ले. A particle is moving, let's say with some velocity v. To this particle which is moving with velocity v, I am applying an equal force of 10 Newton to the right and 10 Newton to the left. Okay, what will be the net force? Net force will be 0, so the body will continue to move with this constant velocity, but at the same time this equal and opposite 10 Newton है ना, ऐसे it will just try to stretch and elongate that particular body. Okay, so second case also elongates, that is not our answer. Third one, if the body is made to fall freely in the atmosphere, tell me which is the only force acting in that case? It's weight mg. And by using that weight, the body simply accelerates downwards, right? There is no equal force to stretch the body. So in the third case, it will not be elongating, and as it is not elongating, and as the question is also to find out that situation which does not elongate, third is our answer. मिल गया तो मिल गया, आंसर मिल गया, मजा भी आ गया. बोल दो जल्दी. हाँ सर, मिल गया. ओके डोकी, आ गया, बिल्कुल, फाइन, राइट, ओके, नेक्स्ट. Anyone बोल दो ना जरा. I you say that है ना. भाई सर मुझे भूख लग रही है बड़े, मैं रिकॉर्डिंग देख लूँगी. ओके बाद में. ओके फाइन फाइन फाइन. नो वरीज नो वरीज. It's a usual thing, right? I just had my food and I made sure that I'll have my food and then only I'll start taking class, because I know if I keep on teaching for next 2 hours 3 hours है ना, भूख तो बिल्कुल लगेगा. Anyone answer? किसी को मिल गया क्या? किसी को मिल गया क्या? आंसर मिल गया क्या? B option I can find from Devika and Miara. Very good. Yes, it is correct. It's option B, which is 16 joules. Okay. Now, question here is, if the work done in stretching a wire by 1 millimeter is 2 joules. Alright, tell me, what will happen to the work we do in stretching a wire? Whatever work we do in stretching the wire, हम काम कर रहे हैं ऐसे जूल ऐसे खींच करके, right? Whatever is the work done, it will be stored inside the body as its, okay, potential energy U. So work done is equal to potential energy, and this value is given as how much? 2 joules. So when it is said that work done is 2 joules, it means that the amount of potential energy stored inside this wire is 2 joules. Okay. Tell me what is the formula for potential energy. Just now we have discussed with one of the previous problem. क्या था? It is half Young's modulus, right? Then strain square into volume, that is area into length. That's equal to 2. Fine. Okay. So half Young's modulus strain. What is the formula? Delta L by L with a square. 1 L on the denominator and this L on the numerator will get cancelled. So formula will be delta L square by 1 L will be remaining at the denominator into area. And इसका value है 2. इसका value है 2. ठीक है? Okay. Now we can also substitute for area also, so that will be a perfect equation. We haven't completed the question, don't worry. Delta L square by capital L into area, this is 2. So this is the first part or the first equation. Okay, fine. Okay, so that's the first part of the question. Let's continue reading. Then work necessary for stretching another wire of same material. अरे material same है तो Young's modulus, okay, which corresponds to the material, that will be same, but with double the radius. मतलब radius in the second case is 2 times r. And length L है ना, length L2, let's say it is half the initial value L by 2, and 1 millimeter, मतलब the increase in length in the first case देख ले it's 1 millimeter, in the second case देख ले 1 millimeter, both are same. Delta L का value it is same. Fine. So only changes are there with area and its length. So we can substitute the new values of radius and length in the next formula, and let's see what is going to be the new value of work done or potential energy. ठीक है. So writing the new work done is equal to, what was the formula? Half Young's modulus, it's the same. Delta L the whole square वो भी same. देख ले, half Young's modulus delta L square by L length. अरे the current value of length is half L or half times L by 2. So I'm going to write it as L by 2 into area is pi, the new radius square. New radius कितना है? New radius is 2 times the initial. So this is 2r the whole square. Okay. Now what all new numericals popped out, we can write it at the left end of the equation. देख ले. This 2 will go up to the numerator, and this 2 square makes 4. So this 2 square, that is 4, and this 2 will make it as 8. What remains is half Young's modulus delta L square by L pi r square. ठीक है? 8 into. अरे do we have the value of this? इसका value हमको पता है क्या? Do we know the value? Obviously, going to the previous page, you know, half Young's modulus delta L square by L area, which is pi r square, उसका value क्या था? 2. We already know. ठीक है. So what we just need to do is substitute कर ले ये इधर. So 8 into 2 हो गया, that हो गया 16 joules. मिल गया या नहीं मिल गया? It was very simple question. मिस किया, अरे कोई बात नहीं. I hope you got the concept. That matters actually. Study for all, sir. Please reply दो. Reply. Question तो पूछ ले. Question क्या है आपका? हाय मनीष, लक्ष्मण, यस. मिल गया तो मिल गया, आंसर भी मिल गया, मजा भी आ गया. Isn't it? हाय ईथन. ओह, नेटवर्क इश्यूज, कोई बात नहीं. तो समझ में आ गया. शैल वी मूव टू द नेक्स्ट वन? अगला क्वेश्चन पे देख ले. हियर वी हैव द नेक्स्ट क्वेश्चन. So those who missed your last question, ठीक है, ये क्वेश्चन अच्छे से कर ले. Okay, do it properly. Try not to make any mistakes here. मजा तो तब आएगा जब एक लेम जोक आएगा. सोचने पड़ेगा, है ना, सोचना पड़ेगा. अभी कोई उत्तर मिलेगा या नहीं मिलेगा? बी और डी. Okay, first you finalize. Okay, आप finalize करके उत्तर दे दे in the chat box. Lakshman is like B option. Let's do it. Fine. Okay. So we have two wires are of same length. Length of A and length of B. वो तो same है. The diameters are in the ratio dA by dB is equal to 1 by 2. The Young's modulus YA by YB are in the ratio 2 by 1. If they are pulled by the same force, force on A, force on B, same है, their elongations will be in the ratio delta L of A by delta L of B question. Okay, and we all know the simple formula for finding delta L in terms of the above values given: force, Young's modulus, diameter and length. क्या है? Starting with the basics, Young's modulus FL divided by A delta L, right? Okay, so delta L is equal to FL divided by AY. Now here we are asked to find out the ratio of change in length. So in that case, two things are common which we don't need to consider during taking the ratio, which is length of A and B and force of A and B. These two things are given as same for both of them. Force भी same है, length भी same है. ठीक है. Now it only depends upon area and Young's modulus, which means what I want to write is change in length is inversely proportional to the product of area and Young's modulus. That's it. क्योंकि given in the question that the force acting on both the wires and length of the wires are the same. ठीक है. So let's do what we are supposed to do. Change in length to the material of A to change in length to the material of B is equal to, it is inversely proportional to the product of area and Young's modulus. So delta A by delta L of A by delta L of B will be equal to AY of B divided by AY of A. क्योंकि inversely proportional है. So A by B will be coming as B by A on right hand side of the equation. Okay. देख ले. Now area, how can we write? Simple, pi by 4 dB square. Area of A, pi by 4 dA square into Young's modulus of B by Young's modulus of A. Pi by 4 तो cancel हो जाएगा. And with the diameter क्या है? dB by dA the whole square. Do we have the value? अरे dA by dB is 1 by 2. So dB by BA, dB by dA, dB by BA, it's just inverse, right? So that will be dB by dA the whole square. Let's not write it again, है ना? dB by dA कितना होता है? dB by dA कितना होता था? dB 2:1, 1:2 तो 2:1 हो जाएगा उसका स्क्वायर. So that is 2 square into YB by YA. YA by YB is 2/1, so YB by YA उसका inverse हो जाएगा, that is 1/2. So 4/2 हो जाएगा 2. So yes. Yes. Awesome. Clear? So we can have the answer as 2, which is 2:1. Clear? Every one of you? समझ में आ गया? Yes? Clear? Everyone clear? Clinic all clear, right? Correct too? हाँ sir. Okay. Young's modeless and old modeless. When we were taking the class, there was some meme. I got it right. I think it was you who sent me that meme. Anyway, yes, hi. Hail Balaji. Okay. I'm also not attending the live class nowadays. Why do I watch the replay? Very good, Devika. I know that classes are there for every one of you. It's totally fine. I can totally understand. Fine. So, अगला question तो आ गया. I hope no one is stopping you from doing this, right? So, जल्दी से कर ले and give me the answer. इससे ज़्यादा सिंपल क्वेश्चन कभी नहीं मिलेगा. Anyone? 10 more seconds last. हमारा पास 10 सेकेंड्स है मेरे पास. चलो 10 सेकेंड्स, उसके बाद कुछ भी हो सकता है जिंदगी पे, तो दे दे. Maybe A. Okay. Anyone else want to give me the answer? Jitendra Joshi A. Lakshman A. Okay, good. Let's solve it. Arey, this is one of the simple direct question. How to do this? Arey, देख ले, steel wire का length is given. कितना? 2 meter. Right? And it is being suspended from the ceiling. When a mass is hung at its lower end, what will happen? The mass will be extending the length of the wire. Right? And the increase in length is being noted as 1 centimeter, which is equal to 10 power minus 2 meters. So question is strain ka value, that is change in length to original length. Change in length kitna? 10 power minus 2. Original length is 2, right? So 1/2 is 0.5 or 5 into 10 power minus 3. With no units, क्योंकि strain is unitless and dimensionless. सबको पता है, because it's length by length, so units will get cancelled and it doesn't have any units and dimensions here. So yes, done, I suppose. Waiting for the answers from every one of you. Okay, so fine. So yes, next one. Next question तो आ गया. And I think this is also Nanu Manu. It doesn't even lie in that range. Okay, so answers. चलो थोड़ा जल्दी कर ले. Okay, so improve your speed actually. So when you come to these live classes and all, so actually you can improve your speed because teachers will be giving you less time. So you can just go to the question jump, okay, and do the question dip, and give me the answer tap. Anyone? Give me some time, give me some rain, give me another chance, I wanna grow up once again. Na, na, na. At least. Okay, so who's going for the option B here? Devika. Shall we do? Okay, a block of mass 4 kg is suspended from the ceiling with the help of a steel wire of radius is given as 2 mm and negligible mass. Array, in the previous question it was a direct question for finding strain, and this is a question where directly we want to find stress. That's it. So you should be basically knowing. Array, for doing this you simply should be knowing the formula for stress. Stress का formula क्या है? The force acting on it divided by area. Right? Okay. Tell me what is the force acting or the force given by this 4 kg body on this wire that is being hanging. Simple. Obviously 4 kg body can only give its weight, है ना? So obviously that is equal to mg, that is equal to 40. Or okay, in the question they ask to consider g as pi square, so we will do it accordingly. Eraser ले लूँगा मैं, eraser लेके, eraser आजा भाई, eraser आजा, ठीक है, eraser आ गया. Okay, fine. Eraser आने के बाद, ठीक है. So force will be equal to mg, m is 4 and g they asked us to consider it as pi square. So force is 4 pi square. Area is equal to pi r square. Radius कितना? 2 millimeter. So 2 into 10 power minus 3 meters. Square कर ले 4 into 10 power minus 6 हो जाएगा. So 1 4 cancel, 1 pi cancel, remaining 1 pi on the numerator which is 3.14. 10 power minus 6 ऊपर हो जाएगा, that's 10 power 6. So it's a 3.14 into 10 power 6 Newton per meter square, and that's stress. Got it? Tell me नन्नू मुन्नू है या नहीं? Obviously नन्नू मुन्नू होना ही चाहिए. ऐसा क्वेश्चन है नन्नू मुन्नू, अच्छा प्यारा सा क्वेश्चन. आ गया तो आ गया, बिल्कुल. Okay, let's proceed. अगला क्वेश्चन. Senorita. Kutti question. So we got another word here for expressing simple question. Kutti question. Kutti in Malayalam means actually kid. So it's not like kiddish question. Chotu question, matlab simple question. Pooja, jaldi se do the problem and solve the problem, sort it out. Okay, this question does no much relevance to this particular chapter other than the word Hooke's law is there. Actually, this has to be coming from the chapter of oscillations. Anyway, that is also being completed, so we'll do it. Okay, fine. A mass m attached to a spring oscillates with a time period of 2 seconds. So tell me, if a mass is attached to a spring and made to oscillate, what is the time period given? Formula is 2 pi root of m divided by k, where k is the spring constant. Okay, ठीक. Now time period का value is given as 2 seconds. So 2 pi root of mass value which we don't know, we'll keep it as m by k. ठीक है. This is the initial case. Second part of the question says, if the mass is increased by 2 kilogram to already existing capital M, we are adding 2 kilograms. So total mass हो जाएगा capital M plus 2. Okay. The period increases by 1 second. Time period तो एक तो increase हो जाएगा. मतलब initially it was t. Now the time period is 3. So formula will be 3 equal to 2 pi root of, when time period is 3, what is the mass? Already existing mass, we add extra 2 mass, so actually it is m plus 2, the whole divided by k. We got the second formula also. First one, second one. Now question is to find out the initial mass, which is capital M. Array, just divide the equation 1 by 2 and square kar le and just cross multiply, get the answer, that's it. So left hand side pe 2 by 3 ho jayega. 2 pi cancel, root k cancel, remaining will be m divided by m plus 2. Okay, now square it off. How much will we get? 4 by 9 is equal to m divided by m plus 2. Okay, I think you all will be doing, and I just cross multiply kar le, space nahi hai, so I'm just writing the answer directly. M will be equal to 1.6 kilogram. Array आसान है, simple है, and let me say this question does have no much pure connection with the chapter of solids. It's actually a question that should be coming for your from the chapter oscillation. So इधर तो आ गया, हम तो discuss किया, and obviously we have completed the chapter of oscillation also for doing these problems and also. Okay, yes, done. अगला question. Any doubts? Water. Good afternoon, Kajal. Good afternoon. ठीक है. You said है, ठीक है. Some prices will be coming to your houses, ठीक है. So just please keep waiting for the courier person. Okay. Now don't ask me, sir, you don't know the address. All the address are within the Unacademy profile. Okay, we have the address of all the students, so don't worry, it will be coming. Anybody else want the surprise gifts? Next one is here. You also said A, Devika. Okay. So I should be like sending one gift to you also. Right? Thank God that I am taking classes in the afternoon time where there is only live 11 students. So I only have to send to a maximum number of students of 10. Okay. So done. How honestly you lie. Okay. So your gift is cancelled. Now only who all gets? I think Lakshman and Devika only now get the prizes. Okay, done. Oh, I already have a gift and that's your teaching. Alright, thank you. So, Sharwari is going for B, Lakshman is going for A, Mihara is going for B. Anyway, let's do this. Okay. देख ले 4 identical hollow cylindrical columns, fine, of mild steel support a big structure of mass 50,000 kilograms, right? Okay. The inner and outer radius of each and every columns are 30 and 40 centimeters respectively. Assuming the load distribution to be uniform, then the compressional strain of each column. Let's say we have a big body like this of some 50,000 kilogram, and now this is being supported by 4 different columns here, right? Okay. And it is said that the mass or the weight given by this 50,000 kilogram body is equally distributed. So tell me, on each of these columns, how much weight or how much force will it be expressing? How much compressional force it will be experiencing. Alright, total is 50,000 kilogram and the weight is 50,000 into 9.8. इतना weight हो जाएगा and this is distributed among 4 cylindrical columns. So each cylindrical column will be having or experiencing a force of by 4. So 50,000 into 9.8 by 4 will be the force experienced by one single leg there. Fine. Okay, fine. Now this is actually like a cylindrical column. Matlab all these rows which is here is having a cylindrical shape like this. Okay, in this part is hollow and the remaining part is being filled with steel SA. Now when we talk about the area on which this weight is being given, right, will it be the entire circular surface area? No, only this much area which we have shaded. So over that area this much force will be acting. So tell me, how can we find out this shaded area? Very simple. Dekh le. We'll use a different color to mark it there. Dekh le. From the center to the external, the inside radius is R2. From the center to the inside circle it is R1. So how can you find out that shaded portion area? That's equal to pi R2 square minus R1 square. So here pi, what is R2? That is 40 centimeter or 0.4 the whole square minus what is R1? 30 centimeter or 0.3 the whole square. Okay, so that will be our area. This is the force and question is to find out strain. ठीक है, tell me formula क्या है? Young's modulus होता है stress by strain. ठीक है, and strain value is equal to stress divided by Young's modulus, isn't it? ठीक है. Now find out the value of stress from here. कैसे? Force we have, area we have, Young's modulus भी दे दिया है. Okay, we'll take a fresh page and write it. So strain is equal to क्या? Strain is equal to stress, that is force by area. Force is equal to 50,000 into 9.8 by 4. By area is pi 0.4 square minus 0.3 square. By Young's modulus भी है ना, देख ले. Stress by Young's modulus will give us strain. So Young's modulus is 2 into 10 power 11 into 2 into 10 power 11. Okay, so mathematics, you guys are the best here, है ना. So how much will we get? We'll be getting a 7.22 into 10 power minus 6. Okay, hi Anshul. Lakshman already gave the answer as mg by 4. Very good. I didn't see that. Okay, so this says you are totally into the class and listening to each and every concept that we discuss. Okay, jaldi se jaakar go and have some food Miyara then. Hello Shraddha. Okay, so no doubts I suppose. Everything is clear, hai na? Simply we have to use the formula of Young's modulus is stress by strain, and for finding stress we need to find force, and we just need to have that concept that the total weight of the body is equally distributed among the 4 cylindrical columns and each will get a weight or a force of 1/4 the total weight. That's it. If you know this, then it's done. ये तो सही question है, ये कर ले. Now I'm good. Can't miss a single part of your class, sir. Arey, go and have something else. You will have to miss my class for the entire life. So go and have something. No doubt, Sharwari, कुछ भी नहीं है ना? हमें दो सर जी, ठीक है, ये कर ले. We'll have to do a bit of binomial expansion formula here, a bit of approximation here for getting the right answer. So I know that you're going to do it. So, kar le. Dekh le. I'll explain. In the meanwhile, you can still give me the answers. ठीक है. You can see that Initially, a mild steel wire of length 2L and cross-sectional area is stretched well within the elastic limit horizontally between two pillars. Can you see these two pillars? ये pillar और ये pillar. इसका बीच पे, right? Initially, this wire was tied like this, a straight line wire, and so initial length of the wire was 2L. Can you see that? Fine. Now a mass M is being suspended at the midpoint. So what that mass will be doing? It will be bringing that wire in the downward direction by stretching the wire. Okay, now you can see that this will be, okay, that inclined portion will be the new length of the wire. So let me mark the new length of the wire as L dash. We can mark it with a different color so that you can easily notice, starting from here as a and till here. So this will be the new length of the wire. Question is, what is the strain? अरे strain का general formula क्या है? We'll go with the general formula of strain. Strain का general formula is equal to change in length to original length. How will you find change in length? Array, new length L dash minus initial length 2L, that is change in length, divided by फिर क्या divided by actual length of 2L. This much. ठीक है. So 2L values we already know. We need to get the value of L dash. कैसे करेगा? अरे कैसे करेगा? It's not a big deal. You know that from one of the pillar to the center of the wire L है, क्योंकि total length is 2L, half the length to L है. Now this is given as X. Can you see? The amount of extension which is in the downward direction is L. Okay. Now from there, can we find out this length? This inclined length, which is the new position of the wire. That is not L dash. L dash is the total length. L dash we call it as total length. This length, let's say 2L. Can we find out that? अरे बिल्कुल simple. L equal to कितना? अरे root of, isn't that a hypotenuse of the right angle triangle? I'll mark A. This is BC. Right angle triangle ABC. Yes. So L, which is the hypotenuse, will be equal to root of L square plus X square. And L dash, which is the total or net length of the wire after the mass is being suspended, or the final length, L dash is equal to, अरे इधर भी एक छोटा L है, इधर भी एक छोटा L है. So दोनों छोटा L add करना है to find out the new length of the wire. So that will be 2 times छोटा L or 2 times root of L square plus X square. Now from this, for easier calculation, I am going to take this L square outside of the root. When L square comes outside of the root, it will be coming out as L. In the bracket, what will be remaining if you take L square from the first term? 1 plus X square second term by L square, because we are taking L square as common out there. Is it clear? So L dash का value ऐसे हो गया, ठीक है. So same thing, substitute it here. Same thing. देख ले. L dash is equal to 2L. 1 plus X square by L square the whole raised to 1 by 2 minus 2L the whole divided by 2L. Okay. So 2L cancel हो जाएगा. What remains is 1 plus X square by L square the whole raised 1 by 2. Now let me ask, how many of you do remember this binomial part? 1 plus X the whole raised to N is equal to 1 plus NX plus N into N minus 1, N into N minus 1 by 1 into 2 X square. Matlab it keeps on going like that. Do you remember? Similarly, here if you have 1 plus X square by L square the whole raised to half, it will be 1 plus, second term was NX. N kitna idhar? Half. So that will be half, instead of X, here we have X square by L square, X square by L square, plus then N into N minus 1 by 1 into 2 into X square. Here we have X square by L square the whole square. अरे मतलब X square by L square itself is a छोटू value. How do I know? अरे X का value बहुत छोटू है. Because the mass once you suspend it, it will be making a very small displacement in the vertical direction. That X का value बहुत नन्नू मुन्नू है. So X by L itself is छोटू. X square by L square is already छोटू, and if we square it again बहुत छोटू हो जाएगा. So we can neglect it. Okay, so higher powers we are neglecting it. ठीक है, what remains? Remaining क्या है? चलो -1 बाकी है ना, -1 बाकी है. So remaining all things are cancelled, -1 + 1 तो हो जाएगा half x square by L square, and there it is. Okay, cool. Is it clear? Not a big question, not a big deal, anybody can answer. And it is actually, let's not call it as a physics question, actually you can call it as a binomial question, right? It's actually a binomial question, not a physics question. It's not so physics and nature. Okay, I think no doubts. I can't find any doubts here in this chat box. I'm continuously looking. So ठीक है, अगला question पे जाएगा, इधर आ गया. Okay. Now if you copy the answer from internet, है ना, you'll get the wrong answer for this particular question. Jack Matthew, is your nickname Glucose because you're damn sweet? Arey, I think the line will be more better if you ask like this. Sir, is your nickname Glucose because glucose always give us energy, right? Because you are damn energetic. What do you say? I'm not telling I'm so energetic. I'm just telling that line will be more good, है once you add the word energetic. Or glucose change कर ले. ठीक है? Sir, is your name Cadbury's? Because you're damn sweet. Wow, I'm giving you idea. Okay, now आ गया. It's time to fight on whose line it is. Anyone? Anyone with the right answer for this? किसी के पास है क्या answer? No sir, we only have the talks about glucose and Cadbury's और कुछ नहीं है हमारे पास. Anything for me? ठीक है, I'll take everything. Lakshman is going for option D. Devika is going for option D. Awesome, awesome, very good. So many people have done the problem by yourself and got the answer. Very good, awesome. Let's do it. Right, okay. Now a bar of cross section A is subjected to equal and opposite forces at its end. Can you see that? On the bar, equal and opposite force capital F is being applied. Okay. If there is a plane through the bar making an angle of naught q theta, can you see this plane CB? Can you see? That is in the figure. CB. Okay. Find the tensile stress on that particular plane in terms of F, A and theta. Okay. Now, what we need to find out? We need to find out the stress that is acting on this inclined plane. Stress ka formula kya? Basic formula for stress is the perpendicular force that is acting divided by the area. Isn't it? Yes or no? Yes. Now here you can see that the external force that you apply F is in the horizontal direction. But in the calculation of stress here, we will be taking that force which is perpendicular to the area. है ना? ठीक है. So that component of force acting perpendicular to the plane will be what? ये theta है हमारा बच्चा लोग. ठीक है? तो if you draw a line like this, ये theta हो जाएगा, ये 90 minus theta हो जाएगा, ये theta हो जाएगा. Okay? Yes. So the component of force in the perpendicular direction to the plane is F cos theta. Okay. So sigma is equal to F, the force acting perpendicular to the plane is F cos theta divided by the area over which it acts. And this area is given A. Okay. This is the area which we wanted. We'll mark it with the red color right now. Can you see that red colored area? It is that particular area which we want to find out because we are calculating the stress acting over that area. How will we do that? Take cos theta. I hope you can see theta here. Cos of theta is equal to adjacent, which is the given area A, divided by area of the hypotenuse, which is area of CB. So area of CB क्या होता है? A divided by cos theta. So cos thetas will go up. So F by A cos square theta. सो यू डोंट स्पीक हिंदी, मुझे थोड़ा आता है, ओके, थोड़ू थोड़ू आता है, बहुत थोड़ू थोड़ू. Yes. So you can teach maths. मतलब seems like you are not understanding the physics part which I am teaching. So seems like, sir, why don't you leave physics and you start teaching mathematics right now? Maybe that will work. अगला question. Next question is right in front of you. Max, I would run away. You don't like Max Miyara? Answers waiting. Anyone? Answers? Okay. So I think I'll just give you the answer. Okay, fine. देखिए, हमारा करेक्ट ऑप्शन है ए. Okay, here we go. Young's modulus of steel is given. Y का वैल्यू दे दिया है. And the interatomic space for the metal, मतलब if we have two atoms, ठीक है, the distance between the atom is 2.8 into 10 power minus 10. The length is given. Find the increase in interatomic spacing, right, for a force constant of 10 power 9 Newton per meter square. Newton force है, meter square area है. Those who don't know force constant क्या है, वो क्या है? Force by area value is given as 10 power 9 Newton per meter square. मतलब on these two atoms which are at the specific length, if we give a force per area value of 10 power 9, what is the increase in its length? Okay, so obviously देख ले, usually we are concerned with a body of some length L, right? On that we'll be applying equal and opposite forces for increasing its length, right? Just tell me, whenever a body is increasing its length, inside what is happening? The increase in length of any body is because of the increase in interatomic distance. मतलब let's say in its initial length, this is the distance between two atoms. So once you apply that extending forces, okay, what will happen? The interatomic distance is increasing, which makes the body to increase in length. Okay, so the increase in length concept is same as the increase in interatomic distance. No difference in that. So whatever is the equation you use to find out the increase in length, same equation can be used to find out the increase in distance between the atoms when external forces are being applied. So what is the formula? Formula क्या है? अरे formula क्या है? Young's modulus is equal to FL divided by AY. Isn't it? Yes. And rearranging this thing, what will we get? And what we want to find out? A delta L. Okay. Delta L is what we want to find out. Delta L is equal to FL divided by AY. F ka value, F by A ka value is given 10 power 9. Okay. Length is it given? Spacing for the metal is 2.8 into 10 power minus 10. Yes, that's given. And Young's modulus value, that is also given, 2 into 10 power 11. Okay. So 2.8 by 2, that will be 1.4. 10 power 9 into 10 power minus 10 is 10 power minus 1. Here 10 power 11 goes up, 10 power minus 12 goes up. So सही option है option A. B और D. वाह वाह वाह, बढ़िया बढ़िया. Devika, अरे Devika, you gave me the correct answer. बढ़िया. Okay. Next one, I suppose. आ गया तो आ गया. अगला क्वेश्चन आ गया. Read the question properly and get the answer. Okay, question is not, I'll just make the correction, right? Not, question is not to find out the increase in length, question is to find out energy stored in the wire whenever there is an increase in length. वही है question. D for sure. Anyone else? Okay, I'll do it. Fine. What do we have here? Right, we have a steel wire ऐसे, okay, which is actually hanging from the roof. Now, its initial length, its car radius, everything is given, right? Now, you won't find any mass that is being attached for the increase in its length. But in the question it says, right, it is the weight of the wire itself. Obviously, if it's a wire, right, obviously it will be having its own weight, and it is its own weight which is involved in the increase in length of the wire. So, in the calculation of force there, you just have to calculate or get the weight of the wire that is hanging, because weight of the air will be acting as the force that is acting for increase in its length. Fine? Okay. Now tell me, what is total energy ka formula? Half Young's modulus, right? Strain square into area into length. Area into length is volume. Now half into. Here we have, okay, so strain value is not suitable here for calculation. So instead we can convert strain to what? Strain is equal to stress divided by Young's modulus. So strain square is equal to how much? Stress square divided by Young's modulus square into area into length. Okay, फिर भी change कर ले. Half 1 Young's modulus will cancel off. Stress is equal to force by area. ठीक है? So that will be square means force square by a square. 1a is already here, so 1 will get cancelled into length. So this will be the final formula for finding out the energy. Half f square by Young's modulus into a on the top L. So we'll write it like this. Half f square by Young's modulus a into length will be the formula for potential energy. ठीक है? Half into. Continue A. Now force का formula. Force is the weight of this particular steel given. Right? How can you find out its weight? mg. And how will you find m? It is not directly given, instead density is given. So force is equal to mg, m is equal to density, right? Into volume. Volume of the wire is area into length, into g, the whole square, divided by ya into L. Arre wah. Now also there is so much to substitute here and make the calculation. Half rho square, a square by a, 1a, L square into L, L cube, g square divided by y. Got it? Yes? ठीक है. Now कुछ भी नहीं है, substitute करना है बाकी है. Half into density square, how much is the density given? 800. So 800 का square हो जाएगा. एरिया कितना दे दिया मेरे बच्चा लोग, एरिया कितना, रेडियस is 6 millimeter, so area is pi r square, that is 6 into 10 power minus 3 the whole square. And what about the length? 5 meter, 5 cube, g is 10, 10 square the whole divided by Young's modulus, that is 2 into 10 power 11. Okay, and how much will we get? 5.43. 5.43 into 10 power minus 5 joules is what we're going to get. Question is simple, but thoda substitution is there which can make you confused here and there. That's it. Else the question is so simple because we have to start from the basic equation of potential energy stored inside the stretched wire. That's it. Okay. अब किया ना, पूरा नोट किया ना सब लोग ने, without leaving a single part. I hope you all have noted down. Yep. Okay, yes. So moving on, next अगला क्वेश्चन आ गया. Seems like Myara doesn't itself know what she's typing in Malayalam in the chat box. Do you know what it means, Myara? It has no relevance to the situation. That I can tell you. Myara done, Lakshman done, noted. Okay, तो अगला क्वेश्चन तो आ गया. सर आप IIT JEE वाले में नहीं पढ़ाता है? नहीं, मैं इधर ही पढ़ाता हूँ. Talking to Jack, good. I hope at least Jack can understand. So, got it? Lakshman, very good. It's option D, मेरे बच्चे. बहुत बढ़िया. Let's see, देख ले. In a wire, when elongation is 2 centimeter, energy stored is E. When the elongation is 10 centimeter, same wire पे energy कितना हो जाएगा? Okay, now we should be simply getting the relationship between energy and elongation, which we will do that. Or else we already have derived this formula. Which one is it? देख ले. This one. Half Young's modulus, strain square, area into length is the formula for energy. So half Young's modulus, strain square, which will be delta L by capital L the whole square into area into length. Okay. Now making the simplification there, L and this L will cancel off. Delta L square remains. 1 L will be remaining in the denominator and area remains. Remaining things will get cancelled. देख ले. We are talking about the same wire, so Young's modulus same होता है, wires का area same होता है, initial length will be same, right? मतलब in the question the only difference that it makes is what? With the change in length. So we can write E, the energy stored is directly proportional to delta L square. So obviously energy in the first case to energy in the second case is delta L in the first case to delta L in the second case, the whole square. What is energy in the first case? That is E. Energy in the second case, which we don't know, I'm putting it as E dash. Now I'm going to just fill in this formula. Okay. What is the change in length in the first case? 2. What is change in length in the second case? 10. So this is 2 by 10, the whole square. 2 by 10 is 1 by 5. 1 by 5 square is 1 by 25. So E dash will be equal to, this 25 goes to left hand side, get multiplied with E. So E dash का value मिल गया 25 times E. Simple. Okay. So basically using our formula and finding out and get the answer. पहले से 4 और दूसरे से 100 और क्या. Done? ठीक है ना. अगला क्वेश्चन इज राइट इन फ्रंट ऑफ यू, सो गो फॉर इट. Same kind of questions. Read it, get the answer. A simple concept of centripetal force has to be applied here. That's it, और कुछ नहीं. That's the only concept that has to be applied here. Centripetal force का concept has to be applied and the answer will be with you. Once it is done, we can start. Anyone? Okay, I'll give the answer. It's very simple actually. A body of mass 1 kilogram is attached to one end of a wire and rotated in a horizontal circle of diameter 40 or radius 20 centimeter with a constant speed of 2 meter per second. This is one end of the wire. At the other end of the wire, we are having a body of mass 1 kilogram and you are rotating this in a circular path. What kind of circle? It is a horizontal uniform circle. How uniform circular motion? It moves with a constant speed defined. Now, if a body is making uniform circular motion, in order to provide centripetal acceleration, even though the circular motion is uniform, there will be an acceleration which we call it as centripetal acceleration. To provide that centripetal acceleration, there should be a force towards the center. Naam hai centripetal force. Okay. Now, tell me who will be providing the centripetal force for this particular mass which is rotating in this circular motion. The wire attached to that mass is actually pulling the mass towards the center and making it move in the circular path and providing centripetal force. Matlab ye ki the tension force developed inside that wire is actually providing the centripetal force. Clear? Aa gaya samajh? Okay. We'll read the remaining part of the question. What is the area of cross section of the wire if the stress developed inside the wire is 5 into 10 power 6? Okay, in this wire the amount of stress developed is given, that is 5 into 10 power 6. Tell me what will be the formula for stress developed? That is force by area. And how much force is being applied on this particular wire? Equivalent to its tension, right? So tension divided by area is equal to 5 into 10 power 6 and area is equal to tension divided by 5 into 10 power 6. Isn't it? Area is equal to tension divided by 5 into 10 power 6. And the tension ka formula kya hai? Centripetal force, which is mv square by r. How much is m? Mass is 1. Its speed is 2 to 2 square. R is radius. Diameter is 40. Radius is 20 centimeter or 0.2 meters. 4 divided by 0.2, 40 by 2, which is equal to 20. Tension ka value bhi mil gaya, that is 20. So this is 20 divided by 5, that is 4 into 10 power minus 6 meter square. 4 into 10 power minus 6 meter square will be equal to 10 power minus 6 meter square is 1 millimeter square. So it will be 4 millimeter square, converting meter square to millimeters. Hi sir, am I late? Okay, let's say you only tell me. Okay, the class starts at 2 o'clock. Someone comes to the class at 3:30. Do you call that process as being late? Will you call it? Hmm? Daily classes. Mostly it be around this 2 o'clock time. Mostly. But time can change. Just like people change. You know? अरे नो वरीज नो वरीज आई वाज जस्ट टेलिंग यू कोई बात नहीं हो गया क्वेश्चन तो हो गया एंड आई होप यू ऑल गॉट इट नेक्स्ट वन good 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 that's the spirit right that's awesome so why nowadays classes at this time ऐसे ही हाई सर सॉरी फॉर इट क्यों बिकॉज यू आर लेट इसीलिए अरे कोई बात नहीं जस्ट ज्वाइन द क्लास okay so anyway I'll explain declare it listen a rigid bar we have of mass m. Okay, that rigid bar is being supported symmetrically by 3 wires each of length n. Those at each end are copper and middle one is of iron. The ratio of the diameters if each of them have the same tension is equal to. So I'll just explain you this question first. Okay. So here we have a rod like this. Okay. So this rod is supported at this particular point by 3 different wires. Outside ones are copper wires. These are copper wires. And the middle one is iron. It says all of them are having the same length. Fine. And the force, tension in the wire or the force acting is the same. Let's say this is T, this is also T. Okay. Now you know that. Right, once this rod is moving down by increasing the length of copper and iron wires here, obviously, okay, it will be moving in a symmetrical fashion. So increase in length of copper and increase in length of iron same ही हो जाएगा because both of them will be coming together ऐसे नीचे है ना. The increase in length is also same, initial length same, increase in length same, tension is also same. Question is what is the ratio of diameter of iron to the diameter of copper. For this we simply should simply we should be writing the formula for Young's modulus. How much it is? FL by A delta L. Now in both the cases as we are going to make the comparison here, force is a constant which is the tension, length is constant, increase in length is constant. So we can say right area is inversely proportional to Young's modulus. Area how will we write? In terms of diameter, pi by 4 d square is directly proportional to 1 by Young's modulus. Pi by 4 is a constant, so d is proportional to 1 by root y. Okay, the diameter of any wire is inversely proportional to the root of Young's modulus. That's it, ho gaya. And what we are asked to find out? Diameter of copper to diameter of iron, that will be a root of inversely proportional, right? So copper by iron will be equal to y of iron by y of copper. Okay, fine. So that itself will be our answer. Option B हो गया हमारा correct answer. only 10 more questions we have, and in that 10 more question, last 5 questions are easy busy question, almost 5, I'll say 4, 5, 6 questions are easy, 4 questions are only what's say numericals. Chahiye, maybe we can finish within half an hour more. Shimply. ये सब अच्छे से सुनेगा ना. Students are like, whenever teacher makes chotu mistakes, when they keep continuously speak for 1.5 hours, they'll note that. But once I say na, this is a very important formula, बच्चा लोग mark it and put it in a box, nobody will be listening to that. वो तो सुना ही नहीं देगा. Once I come to the next class and I'll be like, so this is the important formula which we were talking in the last class. Everyone will be like, sir, which class, which question, which important formula? Isn't that what you have? Anyway, ये तो हो गया. अगला question. Okay, go for the next one. Devika is like, not all the students are like the other students who's really looking into what teachers are saying or into the flaws teachers are making. Okay, next question. So I hope you all can see. Do it. Okay. Answers? Shall I? First option, everyone is going for the first option, 8. Anyway, let's see. You are given 2 wires. हमारा पास 2 wires है. Both are made of the same material, which means Young's modulus of first one, Young's modulus of second one, same है. And are of same length, मतलब length of first one, length of second one, same है. The radius of cross section of the wire 2 is twice the radius of cross section of the wire 1. Same load is suspended from both of them. Force in 1 and force in 2, वो भी same है. क्या same नहीं है, सब same है. If the strain in W1 B4, then calculate the strain of W2. First, let us make a formula for stress and strains. We all know that Young's modulus is equal to stress by strain. So strain is equal to, strain का formula क्या हो जाएगा? Strain will be equal to stress. We can write it as force divided by area by Young's modulus. Now, देख ले, in the calculation of strain here, right? You know that force is same in both the wires. Okay, Young's modulus is same. The only difference is in area because the area is dependent upon radius. ठीक है? So let us write in the next page. So strain is equal or proportional to 1 by pi r square. It is inversely proportional to area. Area is pi r square. So we can write strain in the first wire to strain in the second wire is equal to inversely proportional. So E1 by E2 is equal to R2 by R1 the whole square. R2 का value we already know, it is 2 times R1 by R1 the whole square. 2 square हो जाएगा 4, R1 cancels. and we got it. Answer is option B. Did anyone give me the option B? No. I know that you guys are so brilliant, and so it's totally cool. So got it, Hannah. Moving on. Nannu Munnu question. Like I told you, right, in the remaining questions, most of the questions are either theoretical questions, so there is no much numericals to be done. Okay, Meera. What's the answer for this? Don't say Hooke's law talks about stress and strain. In Hooke's law, it says stress is directly proportional to strain until the elastic limit. So, Hooke's law actually define about elastic limit, which is the final point till where stress and strain is proportional to each other. So, Hooke's law doesn't talks about stress and strain. It actually talks about the elastic limit, right? The final point where till where stress and strains are proportional to each other. So, iska answer correct है D. Okay, Lakshman, very good. Devika, D, very good. Next, agla question. The longitudinal strain is possible in the case of. You all can give me the answer within some seconds. Longitudinal strain is actually associated with the increase in length, right? We are pulling the body and length to increase ho jayega, or there happens a change in length, and there is a change in length, we call it as longitudinal strain, and we obviously know, right, the change in length can only be happening to the solids case, because gases and liquids doesn't have a specific length or something, it keeps on taking the shape of the container, right? So the change in length is only associated with solids, so longitudinal strain is only associated with solids here. So it's option C. Did anyone give me? Devika, very good. Not a D option, Gopika. Okay, it's option C here. Next. The next question is right in front of you. I hope you all can see that. Right? Okay, so do it and give me the answer just like that. Zoom barabar. Okay, are you all ready? Are you all ready for doing this question? Here we go. Dekhle, anyone gave me the answer already or what? Lakshman, option C, yes, very good, it's 100 Newton. Dekhle, a rubber cord of cross-sectional area 1 millimeter square and unstretched length, matlab initial length, that is given as 10 centimeters or 10 into 10 power minus 2 meters, is stretched to 12 centimeter. Initially it was 10, now it is 12. So change in length kitna? Delta L ka value 12 final minus 10, which is initial, that is 2 into 10 power minus 2 meters. Okay. It is that rubber cord is being stretched and released. Okay. So along with the rubber cord, what is also kept? A small stone is also kept. Okay. So when the rubber cord is released, so with the rubber cord, that stone will also be thrown away. Okay, nothing about that is a question. Young's modulus bhi de diya hai. Question is find the tension in the rubber cord. Okay, how to do this? Simple direct formula for Young's modulus, which is FL divided by A delta L. So force that is produced within the string is equal to Y A delta L divided by L. So Y ka value how much? 5 into 10 power 8 given. Area is 1 millimeter square, that is 10 power minus 6 meter square. Change in length is 0.02. Okay, 2 into 10 power minus 2. By length is 10 into 10 power minus 2 or 0.1. This is it. You'll simply get the answer as 100 Newton. Okay. Yes, very good, Devika. Awesome for giving that correct answers there. Well done. So I think we can move on. Agla. Next, Nannu Munnu question. Kya hai? Even if the question is long, yes. These are that kind of questions, right? Even if the questions are long, questions, answers to Nannu Munnu hai. Read. The ratio of change in dimension at the right angles to the applied force to the initial dimension is known as. Okay, what is it? Change in dimension to original dimension in a direction perpendicular to the applied force. I'll tell you. Dekh le. This is a rod actually, let's say, or a wire actually, let's say of initial length, and let's say this is having a diameter of D. Once you apply equal and opposite forces, we know that length will increase, isn't it? Okay. At the same time, you can see that the diameter will be decreasing to keep the volume as a constant. So the change in dimension of the diameter, okay, to its original diameter is in this direction, in this vertical direction. The change in diameter is happening in the vertical direction. Force is applied in the horizontal direction. Now you can see change in dimension of diameter is in a direction perpendicular to the force. Okay, so here the whatever is talking about is this one only, right? Matlab that change in dimension which is perpendicular to the applied force. Here we have a diameter change to its original diameter. Okay, because this change in diameter is perpendicular to the applied force. So what do we call change in diameter to original diameter? We call it as lateral string. Isn't it? Yes? Nannu Munnu, simple सीधा ऐसा question. कोई doubts नहीं है ना? We can go for the next one. Read the question, every one of you, अच्छे से, and give me the answers. Anyone? Waiting for your answers? Okay, I'll explain. We have four wires whose length and diameter, so the first term is corresponding to the length and the second term corresponds to diameter, are given below as of same material. अरे material same है तो Young's modulus तो same है. Y is same for all the four wires of this different dimensions. Fine. Which of these will have the greatest extension? We are asked to compare the delta L value when same tension, matlab when force applied is same, okay, and when all the wires are having the same Young's modulus of elasticity, which one according to their length and area or length and diameter will be having the maximum extension? That's a question. Okay, fine. So let's do this. What is the formula? We all know that Young's modulus is equal to FL divided by A delta L. Okay, so change in length will be proportional to what? Array force and Young's modulus is constant for all the wires, so we don't need to consider for comparison. We'll consider what all? Length, which is different for all the wires, and area, which we can write it as pi by 4 d square. Again, pi by 4 is also a constant, so delta L proportional to L by d square. So among the four wires given here, right, whichever is having L by d square value larger, that will be having a larger value of delta L. Okay, fine. So there is no other method. We'll have to find out L by d square value of all the four options. Starting with first option, L ka value 0.5, that is 1 by 2. D is also 0.5, so 0.5 square, what is 1 by 2 square ho jayega. 1 by 2 is cancel, 1 by 2 will be remaining on the denominator, that 2 goes up, ye 2 hai. Okay, now second case, L and D are 1 and 1, so L by D square will be equal to 1 by 1 square. Matlab dekh le, it is 0.5, 0.5, 1, 1, 2, 2, 4, 4. So when it moved from 0.5, 0.5 to 1, 1, dekh le, the ratio has decreased. Initially it was 2, now it became 1. So obviously from 1, 1 it goes to 2, 2, obviously that value again decreases. Okay, matlab as we move down the options, the ratio of L by D square value is decreasing. So the one with the maximum value is, the one with maximum value of L by D square is the first option, which is 0.5 meter comma 0.5 millimeters. Fine. So हमारा correct answer हो जाएगा option A. आ गया समझ? बोल दे हाँ सर, बिल्कुल समझ में आ गया, अच्छे से समझ में आ गया, खूबसूरती से समझ में आ गया. इसमें क्या है? So next, four assertion reason type questions is what we are having. Okay, so read the assertion, read the state reason wala, and go for it. നന്നായിട്ട് മനസ്സിലായി. ഓക്കെ ദേവിക. Steel is more elastic than rubber. Is it a correct statement? Now, we should be removing that misconcept. Whenever the term elasticity comes, it shouldn't be like that rubber wala properties. It will be like elongating a lot. No. In physics, elasticity is not taught on basis of that. Right? A material which is more elastic, okay, we call it when it has more amount of restoring force. When a particle is having more amount of restoring forces, right, then we call the material as more elastic. Tell me, in the case of steel or in the case of rubber, it can have more restoring force? Obviously in the case of steel. How can I say that with so surety? You take a steel here, right? Now, if I want to increase the length of the steel, I have to apply a large amount of force. बहुत बड़ा force we have to apply. Why? Because the restoring force produced inside the steel is बहुत बड़ा. That's the reason why the external force that we have to apply to increase its length is very huge. समझ में आ रहा है? Okay. So the external force is huge because the internal restoring force inside the material is huge, and this is huge in which one? Obviously in the steel one. Unknown caller. Okay, so we have to say steel is more elastic than rubber. ठीक है, assertion तो सही है. Now reason says for same strain steel require more stress. Stress मतलब force by area. Yes, steel requires more force on it, right? Yes, correct. And obviously reason is the correct explanation for assertion also. So yes, सही है, हमारा first option correct है. Okay. Okay, fine. Next. हो गया. Assertion recent type done. Let's do this. देख ले. Assertion says bulk modulus of elasticity can be defined for all the three states of matter: solid, liquids, and gas. Yes, obviously, because solids, liquids, and gases, bulk modulus का मतलब ये है कि change in volume, right? Okay, so obviously the change in volume is associated with the solids, liquids, and gases, right? So obviously bulk modulus can be defined to all the three. Okay, so assertion तो correct है. Reason में क्या है? Young's modulus is not defined for liquids and gases. We already have explained this because Young's modulus is associated with increase of length, and increase of length can only be associated with a solid, because liquids and gases we cannot specify a proper length. It always take the shape of the container, right? Okay, so Young's modulus is only applied for solids, and assertion also correct, reason also correct, but reason is not explaining anything. So we should be going for the option B here. Okay, fine. So I hope everyone is clear about all the questions and everyone is like, sir, please no more. So, ठीक है. So we'll stop here. Fine. In the next class, we'll continue with a new chapter with new questions and with tons of questions, let's say. बहुत सारा क्वेश्चन के साथ हम will continue. Yes, Lakshman. Okay, great. So, yes, that was the last question. I hope you all have enjoyed the session actually, right? I don't expect assertion recent type for this exam, है ना? Part 2. मतलब second part, term 2 examinations is mainly subjective questions, so you don't have to expect for assertion recent type questions. तो नहीं हो जाएगा. Okay, fine. Now बच्चा लोग, you all would be happy to get some scholarship for your colleges, right? So here we have the Unacademy Prodigy Scholarship test that is happening for students from 7 to 12. If you can get a very good rank here, you can get scholarship and win scholarships up to 10 crore. So don't miss your chance. Next exam is on February 13th, the day just before our Valentine's Day. So obviously before Valentine's Day, this is your chance to grab some prizes and money, okay, so that you can gift your loved ones, let's say. Anyway, you can enroll it for free with the code of AMB10, and time is from 12 to 1 p.m. The schedule is given here, as you all can see. And the awesome rewards is rank 1 MacBook Air if you'll get awesome. ठीक है. Second and third rank Apple iPhone, Apple iPad, बहुत सारे prices are waiting for you, so don't miss it. Okay, now here we have what do we have? Yes, the courses that is happening here, you can be a part of it. Special class timetable, I'll be updating you. Special classes are always awesome. We all know with the live chats, questions tab, live polls, leaderboards. Okay, now everyone, thank you so much. You all can like the session if you have liked it, if you think that the class was awesome and it helped you. And do share the class with all your friends, subscribe to the channel, and thank you so much everyone. See you all in the next class. Till then, bye bye and take care and happy weekend. Okay, bye.